do these two supercars have in common? They both have a powerful masculine appeal with feminine curves. They both have a futuristic appearance. And they're both built to run on biofuels. The Aero X is all ethanol, but the Attack is powered by 100% biodiesel and built by 100% kids.
It's a great pleasure to work with urban students that have developed a car that is truly a part of the future.
Yeah, the first time I ever turned to Richmond, I was 6 years old. I'm Kevin McKnight.
Victor Webster.
I'm Jeffrey Daniel. I'm Lawrence Jones.
My name is Okonsi.
My name is Joseph Pack.
I'm Jesse Jones.
I'm Bruce Harmon.
And I'm Simon Hogger, and this is our vision of the future.
We wanted to make a fuel-efficient car that also looks good.
We just kind of stumbled upon biodiesel. It is a fantastic fuel.
Biodiesel is basically diesel with all vegetable oil.
Most diesels can actually run biodiesel.
But what slight alterations did they make for it to run on pure vegetable oil?
Diesel engines actually use heat instead of spark plugs to ignite the fuels. This wasn't too difficult.
Here's a TDI turbo diesel engine, 1.9 liter.
This is a performance fuel filter we had installed. And these are the special biodiesel lines we had to use.
So you can't just pour in unrefined French fry oil.
Because it biodegrades sometimes the fuel lines if it's not the proper material.
Now you can put it in there, it will run, but it will clog your fuel injector, so we just have to clean it.
These are performance injectors we had installed to add more performance to the car.
And what does all this add up to?
So far, we got 55 miles per gallon.
It goes 0 to 60 in about 5 seconds.
We also raced the car, and we won first place this year and last year.
I'm a math and physics teacher. I'm not an environmentalist, and as you learn about the benefits of biodiesel, it really makes you scratch your head. It's fantastic for the environment. It has almost zero net carbon dioxide output.
You won't get sick off of what's coming out the muffler or the tailpipe.
The next step for their creation? Add an electric motor and create a hybrid. But that's down the road.
We got 55 miles per gallon now, but when we put our electric motor on there, we're trying to aim for 70 miles per gallon, or close to it.
We want to make it like a hybrid that's cool and nice and fast. It really takes a sports car and a hybrid, and it really makes it look good.
I like the shape and the body and the model of the car because it's like a Lamborghini and a Maserati mixed together. I've been interested in cars since like the 7th grade when my mom brought her car home and it had a click or a knock here. I try to go in that engine and look to see what's wrong with it. Now I know how to diagnose things and how to fix things.
To see students work on something meaningful that's really on the cutting edge, to come up with great ideas on their own, to be a part of helping them come up with great ideas is a very rewarding experience.
We have already entered rehab for our gasoline addiction. Step 1, ethanol. Step 2, biodiesel. Step 3, hybrids. Those gas-sipping cars with 2 fuel technologies under the same hood. They create longing in our hearts as we stand at the fuel pump. And everybody's thinking about crossing over.
Hybrid technology is one that combines really 2 propulsion systems at the same time. We take traditional internal combustion engine, combine it with some type of electric motor or electric machine.
Remember Mickey Bly? He's the hybrid guy at GM's Proving Grounds in Milford, Michigan.
What we're trying to do in the automotive industry is combine those things to get the highest efficiency out of the vehicle possible.
The reason you use less gas is simply because the engine doesn't always have to ask for it.
When you come to a stop, the internal combustion engine just turns off, and electrically we continue to keep the vehicle alive.
And where does that electricity come from?
We have to put a large battery system inside the vehicle to be able to take some energy, store it, and then release that back into the propulsion system.
That battery adds more than 200 pounds in a mid-size car, which unfortunately creates a paradox.
Because as the vehicles get heavier, they slow down, they consume more fuel during the operation.
Right now, the battery is commonly nickel metal hydride, which is still fairly heavy.
The battery technology is evolving every day.
As technologies are introduced, the battery weight goes down and its performance goes up. Today, hybrids are the most sought-after vehicles on the road. But as battery capacities increase, it's clear that hybrids are a giant step towards, well, the next step. 100% electric cars. They take us back to technologies that are as familiar as turning on the light. Simple technology. Electricity turns the wheels independently as current is sent from the battery system. And as basic as turning up the volume, the driver turns up the throttle. In the late 19th century, electric vehicles outsold all others, and then they were history. In the late 20th century, electric vehicles were the future, and then they were history. But now, they're back for good. Electric cars are the future. They're hot, they are fast, and they can take you hundreds of miles on a single charge. This is the Tesla Roadster. Born in California, it puts Silicon Valley in contention to be the next Motor City.
A network of batteries managed by a network of microprocessors is perfectly reasonable for Silicon Valley. My name is Martin Eberhard, and the Tesla Roadster is the beginning of my vision for the future. A typical electric car in the past has had a range between 40 and 60 miles, and this is not good enough. We felt that we needed to be at least above 200 miles to make the car comfortable to drive. So we aimed for 250 miles, and we achieved that.
So what do they do differently?
We used a different kind of battery than was used in electric cars in the past. This time we used lithium-ion batteries.
Laptop batteries.
They store more energy in the same amount of weight and the same amount of space. Instead of 4 or 6 cells, as you would find in a laptop computer, we used 6,831 cells. A few more.
So how does the Tesla get powered up?
Come home, plug the car in, and you go have dinner and you go to bed. You wake up in the morning, you unplug the car and drive off. You have a full tank every morning.
It's that simple. No more gassing up for the week or worrying about leaving extra time to swing by the station in the morning. It's about plugging in and waking up with 250 miles worth of charge.
Imagine driving 250 miles and paying $5 for that distance. On a comparable gasoline-powered car, you'd pay somewhere between 5 and 10 times that amount.
$300 a year without using any petroleum.
It doesn't burn any oil whatsoever, and it allows us to produce its fuel any way we want to.
Electric cars have no emissions, but the source of electricity production might. So our farmers may be providing biomass or planting a lot of windmills for emissions-free electricity.
We can make electricity with wind farms, with solar, with whatever technology comes along. The cars don't have to change.
So we've got plenty of clean options to recharge the Tesla. But what exactly do the batteries do with all that current?
It delivers the energy to an electronic control system. That control system feeds a 3-phase AC motor. My name is Malcolm Powell. Our electric motor spins from 0 RPM all the way through to 1350. Achieves its 0 to 60 in around 4 seconds, and that puts us in Porsche Ferrari territory.